Imagine you're in the midst of a medieval warfare, using a catapult to throw flaming balls into the enemy's fortress. This demonstrates the principles of elastic potential energy and specific heat capacity in a dramatic way. Elastic potential energy and specific heat capacity in 5 minutes. We've learned about energy and its forms. If you haven't checked it out, now it's a great time to do that. Work in physics is just change in energy. So when work is done, energy is transferred. This might get stored and have the potential to do other things. Let's take a spring. When a spring is stretched or compressed, work is done on the spring, which results in transfer of energy. This energy is stored and has the potential to rivet or even possibly deform the spring. That energy is called as the spring's elastic potential energy. It is proportional to the extension or shortening of the spring. Mathematically, it is expressed as E equals half k E squared, where k is the spring constant and E is the extension. Remember, the extension is in meters, spring constant is in newtons per meters, and the energy is in joules. We know that work and energy is just practically the same. So what if energy is supplied to an object? Let's take heat energy. When heat energy is supplied to an object, the molecules inside the object absorb the heat energy and it results in an increased internal kinetic energy. This is because the heat causes the molecules inside the object to move faster, resulting in an increased kinetic energy. Obviously, the object is going to get hot. But how hot depends on the thermal capacity of the object. Thermal capacity, in turn, depends on the mass and the material of the object. And there is something that relates all of these things, and that is called as the specific heat capacity. The specific heat capacity of a material is the energy required to raise the temperature of 1 kilogram by 1 degree Celsius. Mathematically, it is C equals delta E over m delta theta. Remember that the mass is in kilograms, change in thermal energy is in joules, change in temperature is in degrees Celsius. And that gives the unit of specific heat capacity to be joules per kilogram degree Celsius. For example, the specific heat capacity of water is 4,200 joules per kilogram degree Celsius, which means it takes 4,200 joules of energy to heat 1 kilogram of water to raise its temperature by 1 degree Celsius. If you found this video helpful, a sub would be much appreciated. It motivates us to keep making content that is free and accessible to everyone. I'll see you in another video. Peace.